welcome to all for the another one video. So we are in the quantum mechanics. Here the topic is probability and correspondence principle. So before discussing this topic, we are very well known about the degeneracy states and non-degenerate states of quantum energy levels, and we are very clear how to derive the eigenvalue and eigenfunctions of one dimension, two dimensional state and three dimensional state. So now we can move to the probabilities and correspondence principle. So according to the Niels Bohr, any new theory, any new description of nature must agree with the old theory, wherein we get correct results. This conceptual thinking exactly matches with the classical theory, that is the old theory, and the quantum theory, that is the new theory. So what is the correspondence principle? We can say the statement. For a large value of principal quantum number n, the quantum mechanics merges with classical mechanics, that is, the classical theory and quantum theory will have the same results at this point. In other words, we can say that the quantum mechanics under certain limits like high energy or high mass or high length or high quantum number, etc., it approaches classical mechanics. That is, now we can understood for a higher values of quantum number or any of the higher values, the quantum mechanics approaches the classical mechanics. Finally, the new theory becomes a old theory at the maximum limit. This is the correspondence principle. This is called as, this higher value is called as a probability. So quantum mechanics for the certain limits, it's converted to a classical mechanics. Next, so for this one we have two proofs. One proof is that is using eigenvalues. The another proof is by using the eigenfunction. We can prove the correspondence principle, how it can converse from quantum mechanics to classical mechanics for a certain limits. So now we can discuss about the proof 1 by using eigenvalues. There is a figure which shows and we know the eigenvalue and eigenfunction equation. So let us discuss how the quantum mechanics merges with classical mechanics for a particle enclosed in a one-dimensional potential well. The one-dimensional potential well having an eigenvalue formula En is equal to n square h square by 8ml square. Let this equation number 1. Here the energy eigenvalue for a particle is n plus 1th level. We can improve the nth level to n plus 1. So wherever the n is there, we can put n instead of n plus 1. Sorry, n plus 1 instead of n. That is a n plus 1 is equal to n plus 1 the whole square h square by 8ml square. Let this equation number 2. Let us find the difference between the change in energy level from n plus 1th energy level to the nth energy level. So we have to get a difference between the change in energy, that is del E is equal to E n plus 1 minus En. We have two equations for En plus 1 and En, that is 1 and 2. So substituting equation 1 and 2 in this equation, we can get del E is equal to n plus 1 the whole square divided by 8ml square into h square minus n square h square by 8ml square. Finally, we can after rewriting equation and after getting some derivations, finally we will get del dot E is equal to h square by 8ml square into 2n plus 1. This is the fourth equation. So to find del E by E, that is we are going to prove a probability and correspondence principle. So for that one we need to find del E by E, that is the change in energy is del E. From equation 4 and equation 1 we can write del E value, we got it now from equation 4, that is h square by 8ml square into 2n plus 1, and we know the equation E value, that is n square h square by 8ml square. We can bring the n square in last one, so because because the numerator and denominator have a common values of h square by 8ml square, so it can be cancelled each other. So 2n plus 1 divided by n square is the answer. Then this 2n plus 1 have a common denominator, so split it. 2n by n square plus 1 by n square. In this 2n by n square, n going to be cancelled, so del e by e is equal to 2 by n plus 1 by n square. This is the equation number 5. For a larger values of n, that is, if n tends to be infinity, the equation 5 becomes, that is, we can put n instead of n. For n value is infinity, 2 by infinity plus 1 by infinity square. That is, anything by infinity can be considered as a what? Del e by e is equal to 1 by infinity. Then 1 by infinity is nothing but 0. The above equation 6 indicates that the larger values of n, the difference between the energy level approaches 0, and hence we can say that for larger values of n, the energy values are continuous rather than discrete energy values. That is shown in the figure. See this figure. It is a potential wave with the x is equal to 0 to x is equal to L. That is, it have a with the L. There is a small dot is there. So in small circle is there. We have to consider this is a one particle. This particle have number of energy levels. See the diagram. There are more number of energy levels. It indicates that is a discrete energy level. Show discrete energy levels means that is a quantum mechanics. If it is a continuous energy levels means that is a classical mechanics. So what happens here for a larger energy values? It starts from x-axis bottom to top means the discrete energy value is going to be a continuous one. So we have come to the next proof. That is using eigenfunction. We can also verify the same using the eigenfunction as follows by finding the probability of wave function. The probability is, we know the wave function for a particle enclosed in a one-dimensional potential well is psi n is equal to root of 2 by L into sine n pi x by L. See here the wave indicates. The probability wave function is given here for values in x-axis. The probability of wave function in n state shall be written as a psi n square. That is the probability. Note it one. Probability value, it is a psi modulus of psi n square. See this figure. From the bottom, there are more number of energy levels is there. Here we started from n and we have ended up to 20. N is equal to 1 is the lower value and n is equal to 20. We can consider it as a larger value. We are concentrated only on the wave function, that is psi n square. So see the first energy level. We have only one wave. Only one wave. There is only one probability of finding a particle or electron. That is E1. For n is equal to 1, the energy level is E1. The probability wave function is psi 1 square. We got only one wave. Now move to the next energy level. N is equal to 2. That is the energy level E2. We have two waves. So there is a 2 probability to finding a particle, that is psi 2 square. Then if it is a third energy level for the E3, we have 3 waves. There is a 3 ways of probability to finding a particle. Suppose if it is a 10th energy level, that is E10, we have 10 waves. There is a 10 probability, that is 10 maximums we got. If n is equal to 1 means 1 maximum. N is equal to 2 means 2 maximum. N is equal to 3 means 3 maximum. If n is equal to 10 means 10 maximum we will get. There is a 10 ways of probability of finding a particle. See the wave sizes, wave maximums and wave heights from n1 to n10. You have find some differences of height and some differences of breadth. For n is equal to 1, the complete potential was occupied by one maximum. If n is equal to 2 means two waves are going to be occupied. Comparing to comparing to E1 and E2, the wave is going to be shrinked. For N10 is more shrinked. For N20 there are 20 maximums are there. So the very minimum breadth is there. Suppose if it is infinity means, consider what happens. Infinity means the number of possibilities of finding possibilities are there to find a particle. That is more number of probabilities we get. But what happens, the discrete energy level disappears, and finally the distance between or breadth between the maximums and breadth between the waves will be shrink. So finally the discrete levels disappears and we will get a continuous energy levels only. That is one on the overlap is takes place. Overlapping takes place. If overlapping is there means there is no discrete energy level. Automatically the discrete is disappeared. So we will get a continuous only. This says the correspondent principle. That is the quantum. For a certain limits, the quantum mechanics converted as a classical mechanics. Wherever the discrete, there is a classical mechanics. Wherever the continuous energy level, there is a classical mechanics produces. So this is the diagram which is explained here. So the slide shows the for a 7n is equal to 10, for n is equal to 20, what happens. And finally we are coming to the classical proof. If we see the energy level of the particle classically, it appears to be a dotted line only, which implies the probability of finding the particle is constant. By merging the quantum wave function for n is equal to 20 and classical function for n is equal to 20, what happens? We can see that the probability of finding the particle in a quantum wave function is almost the same as that of the probability of finding the particle in classical wave function. So come to the conclusion. Thus for the larger values of n, that is for the larger values of energies E, the normalized quantum wave function merges with classical wave function. That is, we are coming to the point, quantum mechanics merges with classical mechanics. This is the main point. This is called as a correspondence principle. Now we proved the correspondence principle. See the last figure. How the particle behaves. Thank you.